evening. In the last session, we started with coverage, right? So just basics, basic concepts are completed. So today we'll start with the code coverage. So So what is the difference between code coverage and functional coverage?
Code coverage just checks how many code is covered in our design, and functional coverage checks the functionality of our design.
Okay. Any examples? Hmm?
For example, if we use any condition in a any conditions or any statements, particularly which do some particular functions, to check that function works correctly or not, we use functional coverage, ma'am. For example, use sometimes we use some logics or use some boolean conditions, boolean logics and all, ma'am. To check that, we use functional coverage, ma'am. Code
Okay.
coverage means the total code we return. Whether all code is covered or not, to check that code coverage is useful.
Okay. Okay. So yeah. Code coverage is nothing but, as we discussed before, mostly design side we use code coverage, and verification side we use functional coverage. So in design, whatever we want to check, like any blocks, procedural assignment blocks or continuous assignment blocks, or number of lines conditions, or finite state mission, or any toggle path. So all these things we will check with the code coverage. Okay, so the simulator tool will automatically extract the code coverage from the designer. Coming to the functional coverage, for functional coverage we need to write the bins. Okay, so which bins will hit the test cases. So in the next session we will discuss detailedly on the functional coverage. What are the different types of bins are there, like transition bins, wildcard bins, illegal bins, toggle coverage. There are different coverages are there in functional. Mostly our target is functional coverage. Okay, practically in system verilog and also in UVM, both are same. Anywhere we write the same coverage. Okay, so we'll look into both the system verilog, how to write, and verilog, how to use in verilog. So today code coverage will discuss into like different examples. Okay, what is mean by conditions, how conditions are verified, and toggle or path related or finite state mission. So we'll check how to write a simple code coverage. Code coverage is a simple, just we need to enable the coverage and write. But for functional coverage we need to create the bins. Okay, we need to create coverage groups, cover groups and all. So coming to the cover group, so what is mean by a cover group? Cover group is nothing but which encapsulates the specification of coverage model. Okay, so coverage model means what? Suppose if there are 100 test cases, as I told before, in the design functionality, whatever the functionality of the design, we need to create the bins. Okay, so bins are nothing but which hit particular functionality, so that automatically we get the report. In the report the percentage of coverage will be increased. Okay, so that thing we will check with the bins. We will write the bins according to the functionality and according to the test cases. Okay, so those bins we need to write within the cover group. So for constraints, we use the constraint, right? So how we are writing the constraints based on constraint keyword, we write within that. Like generate block, we use generate block, generate and generate. Like that in coverage, we use cover groups. Okay. So in the cover groups, entire specification related coverage model, everything we will include in the cover group. Okay. So a clocking event that synchronizes the sampling of coverage points, a set of coverage points, cross coverage between coverage points, optional formal arguments, and coverage options. So as I told in the last session, every tool have their own coverage options. Okay, suppose in EDA Playground we have different tools, all deck tool, Questa, Sim, or Synopsys, Cadence. So every tool have their own commands. Okay, so commands are nothing but which we create user defined as per the requirement, as per the test case name and the different suite names or configuration names, we create our own commands. Okay, those things you will learn once get into the industry, because there we have SOC level, everything we do in SOC level. So there will be lot of configurations and different test cases, different suites will be there. So those are very different, and whatever we are writing here, those are simple commands to extract the coverage and to upload the coverage. Okay, so next, coverage group. So here is the syntax. Cover group, name of the cover group, and group. So we create the one instance for coverage, cover group, and call the coverage sample. We call it as a sample. So in normal test bench, so if we write anything, how we do the sample, just calling. Suppose task or function is there, we just call the task name and function name, right? Like that in coverage we do sample. So coverage dot sample. Okay. So see here, sample method. So coverage should be triggered to sample the coverage values. Sampling can be done using any event expression, edge, endpoint of sequence, or event can be omitted calling sample method. So this is how we use the sample method. So cover group CG is the name of instance of the cover group. So next CG inst dot sample. So that is how we use the sample method. Next, cover points. So cover points are nothing but bins. Within the cover point, we write multiple bins. So if you see the program, syntax, program main or module, within the module also we can write. So y is one variable, 3-bit size, and values $356. So these are inputs. 356 are just input values. Okay, suppose a 3-bit combination. 3-bit combination means how many number of possible values will be there. 8 number of possible values are there. Okay, in that 8 number of possible values, through the coverage we are going to cover the functionality of 356. Here we are considering in terms of values, but in real time we write test cases. Okay, test case, one test case is covered for particular scenario, another test case is for some scenario, write operation, read operation, or some different transactions. Okay, so like that we need to write, but here just for um, understanding, the different values are taken. And cover group CG cover point. So this is the name of the cover point, and here cover point is a keyword y. Okay, so for this y we create number of bins. So CG, for cover group CG created the instance. Okay, and for each values of I, begin by equal to values of I. So CG inst dot sample. So this is how we can do the sample operation. Okay, so we'll see, we'll do the coding in EDA. Next, coverage filters. Filters are nothing but normally we use if else condition, right? So like that here we use if IFF. Two F's will be there, IFF. If reset is 0, then what is the condition? If reset is not 0, what is the condition? Just Next, coverage bins. Bins are nothing but it associates a name and count with a set of values or sequence of value transitions. So here, so bins and all comes into functional coverage. So functional coverage we will discuss in the next session. As of today, we'll discuss a code coverage. Okay. So how we will write the code coverage. So example for code coverage, I'm taking any example. Simple example we can consider. Suppose any adder. So just we write the continuous assignment. Assign sum is equal to a plus b and module. Okay. So here we write the test bench. So in the test bench, how we can write um, module test bench create both input and output. So we can use a logic data type here because it's a system verilog, right? No need to write reg. And then DUT. And within the initial begin. So here we'll take different scenarios. So at initial 4-bit decimal value we can assign. In functional coverage we do different sample, and in code coverage we do different sample. Okay, so next, end of simulation, just put end and dollar finish at some time unit. So how we will write the code coverage for we can write in a cover groups. So cover group and all we will check in the next session. So in a simple way, how we can generate the coverage report means we need to use one system task called coverage control. Okay, so just open the waveform dump file. So here we can write the coverage control. So what is the system task? Dollar coverage control enable. We need to do control enable. So one. So one means enable. Zero means disable. So enable the coverage collection here so that we can display the uh, dollar display, coverage will be collected. Okay, so this is how for simple code coverage, but for functional coverage it is different. So here we need to add run.do file. Okay, run.do file means we need to add some commands because we need to extract, right? We need to upload and extract. So for that we need to use some commands. You can find commands in Google also. No need to learn those things. So here are a few commands. Run.do. So we sim access plus or run all abcd, just a variable, and report database db f cover, and here cov.text. So in this file we will get the coverage. Okay, so exit. Same. So just copy this and copy here. So we need to use run.do TCL file. It's a TCL script. Okay. So use run.do file and download file after run so that it will download the file. So file will be run here. Open that. So different files will get here. Dot bash profile. Coverage file is not generating. Coverage database is turned off. Script execution is terminated due to errors. Okay, I will check this point. Okay. So next, so mainly coverage control we can enable by using this dollar coverage control and for branch code. So if it is a branch code, so mostly branch in the sense if else or case statements. For if else and the case statements we write the branch coverage. Okay, so like if you take any example, any multiplexer or comparator, for if else we write the branch coverage, so less than or equal to or greater than or equal to whatever it checks. Okay, next to toggle coverage. So what is mean by toggle coverage? Toggle coverage is nothing but 0 to 1 and 1 to 0 in 0 to 1 and 1 to 0. In code coverage also we have the toggle, because while we are doing a clock, when we generate the clock or reset, there we find the toggling, right? So in the counters, mostly in the counter operation, we find the toggle coverage. So whether so in the UART program, yesterday we have seen in UART code we written the counter logic. Suppose if reset is high, count should be 0, else count will be count plus 1. So in this case, count equal to count plus 1. For every clock cycle, it is going to toggle. Okay, so every clock cycle, whether it is toggling correctly or not, we do by using the toggle coverage. Those things we'll write within the bins. Okay, so like that path coverage. Path coverage means uh, like all possible combinations in if else. So if we'll write if statement, else if, else if, else if, else. Okay, that is a path. So whether the path is getting properly or not. To check that, we use the path coverage. And functional coverage, you already know about functional coverage. And next thing is um, wait. Okay, here next thing is a line coverage. Okay, so line coverage in the sense, suppose if there is a line piece of code, so whether it is executing properly in the line by line or not. So we will check the line coverage and also branch coverage. And next thing is expression coverage. Expression coverage means here whatever we write. Assign sum is equal to a plus b. So mostly by using a continuous assignment statement. Okay, so that is a expression coverage. So every design we write the test bench. In the test bench we enable the coverage. It is the same process for every code in the coverage code coverage. So but it is not getting coverage report. I will check once in the next session. I will show you for few of design for branch coverage, expression coverage, and path coverage. Every example I can show you. And finite state machine coverage. Finite state machine coverage means in FSM there will be number of transitions, right? So state 1 to state 2, state 2 to state 3. So every transition will check the coverage whether transition is happening or not. That is a finite state machine coverage. And cross coverage will be there. So how we write the cross coverage? Cross coverage is nothing but it checks the combinations of multiple variables. Okay, so it all possible combinations are generating or not. So it will check the possible combinations between suppose here a b is there. Same example I'm showing you. Suppose if I take a cross coverage here, input a b and output sum. Okay, so here I am taking a, it is in system verilog we use always comb only for combinational logic circuit. Okay, always comb begin. So here we can write sum is equal to a plus b. So cross coverage is nothing but a b or cross. Okay, so for both we check the number of combinations. All combinations are working correctly or not. So and in the test bench, what do we write? Same here, DUT, and we write the coverage group. In the cross coverage, we use the coverage groups. So cover group, name of the cover group, CG or anything. So for this, we need to write the cover points. Cover point. So check the syntax here. See, like this. Cover group, cover point, and end group. And for cover group, we need to create the instance, and through the instance, we can run. Okay. So here I'm taking cover point A. No need to mention name. Okay. So this is cover point Y is the name of this cover point. Okay. So if you want to mention name, you can mention, or directly we can put like this. So next cover point will be B. So here we write the points. In functional coverage, mostly we use bins. Okay. Next, cross coverage. Cross coverage in the sense we need to write like this: cross A comma B. So for which combinations you want to check. So cross coverage between A and B. End group. So like this we can write. Now for this coverage group, we need to create one. Suppose CG is the instance. So for that we can create one instance CG inst. In the initial begin blocks, here we can I have created these examples, right? So here I can create instance equal to new, and for easy way I will write a is equal to 2 bit, okay, not 3 bit, just consider 2 bit so that for combinations it is easy to take, okay. So 2 bit means the sum will be mostly, output will be in a 3 bit, or also we can take 2 bit. Next here also, now a equal to 2 bit binary 0 0, then what is the b? 0 0 0 1 1 0 1 1. So take the delays. So it's 0 simulation time. Next at 10 simulation time. Okay. So now we need to do sample. Okay. Next, these things are not required. Okay. So run. Sum is not a valid left hand side of procedural assignment. Okay. So we can put which, or else we can put logic also, no problem. We can put logic. What is the error? Syntax error at the line.
We'll be declaring logic before the size you gave, like after that.
Okay. Last instance before TP. So here we will have the execution elaboration process, main thread initiated, kernel process initialization, and create the instances. Fatal error is getting at cov.sample.
Basically, we will sample like for every input change. So you sample for all, so you don't take all the samples. I mean, all input conditions, I think. So you need to give like for every input like a sample.
Okay, then A dot COV dot sample like that, right? Um,
Yeah, COV dot sample for every like 10 nanoseconds delay. You mentioned for every 10 nanoseconds, you're toggling AB values, right? So you have to give like everywhere, like after every statement.
yes. Now we got. Actually, I given different name, not COV. Here, instance name is CGIST. So that's why we didn't got. So what are cover groups and what are uncovered? We get the status from here. So cross coverage.
It,
So
Can
it,
you try
it
to
will
give the sample of like end of every statement, like every input AB, so that will coverage will be different.
Yes,
Can you try doing
now it
that
will take a 33 line samples only. It will
only?
consider
Yeah,
33
only
samples.
the last line sample. I don't
Hmm.
consider like every, yeah.
okay.
Or you can do like the repeat and dollar random, and
Yeah,
every time it will take that.
yeah. Instead of like giving like every day,
Can
like
write
can have like repeat statement
option
and
dot.
give sample.
We can write this option also. Option dot per instance is equal to 1. In that case also we will get. Again, it's failed.
Option that per instant will be only in the cover group we have to.
Yeah. Okay. Now we'll get 100% coverage. So here number of hits still it is uncovered.
Because it's only sampling the last value, like 33 line.
Wait, wait. Okay. See here, everyone. This is how we get the coverage report. Okay, so for any tool, whatever the tool you use, same will get here itself in the description or in the coverage report. So you can download the files also. So here if you see COV file, in the COV file also will get the coverage report. Okay, so here you need to check how many number of hits. Hit is nothing but we write the number of bins, right? So in that number of bins, how many are possible combinations? How many possible combinations are hitted? If any holes are getting, holes are nothing but which are not covered. Okay, so suppose in this case possible combinations are 4. Okay, but we are doing sampling at here. Okay, sample at last value. So what happened, it is taking only at last value. Okay, so for remaining if you want to do sample for remaining, we need to add sample option for all. Okay, suppose in 100 only 4 possible combinations are there. Okay, so in that how much how many number of possible combinations are covering, based on that we get the coverage report. Okay, so here coverage group covered number of hits percentage. So in the hits we have the percentage. In suppose if there are 4 possible combinations, if any one possible combination is hitted, so 25%, 2 combinations hitted 50%, like that how many combinations are there, based on that we get the coverage report, and we'll get the status which are uncovered and which are covered. Okay, so here auto bins 0 1 2 3 or combination, different combinations. In that 3 is hit. So see here at 3 we are getting a 1. Okay, that means 0 1 2, these 3 are not hit. So what is the coverage percentage in 100 percentage? Four possible combination, four possible combinations means four different 25 25 25 25 100 by 4. Okay, so in that only 1%, one combination is hit. So we get the percentage as 25%. Out of 100%, 25% is getting. Okay, so remaining what are uncovered? Uncovered or nothing but holes, we call as a holes. So here 0 0 0 and last one is covered. Okay, and next cover point, these are different cover points for A and B. We took two cover points, right? One is for A, another is for B. So in A also, one is covered, remaining all are not covered. So we need to cover those because our final goal is 100%, right? So in the cross coverage 6.250, compared to both A and B, only 6.250 is covered, and that too auto 3. Okay, auto in the sense automatically, because we didn't created any bins here. If you create any bins, it will generate which bin is covering here, but we didn't created any bin, so automatically it is generating. Okay, so this is how we check the coverage. Now our main task is how we can improve the coverage report. Okay, so 0 to 25%, 25% to 50%, 50% to 75, 75 to 100. So in the real time, whatever test cases are not hidden, based on the test cases we will work, we will fix the error, we do the debugging of the particular test case, or if any functionality is not matching to the test cases, we will write extra test cases to match the functionality. Okay, so that we can improve the coverage and whole design will be covered by in the functional coverage. You will get that clarity mostly. Okay, and so this is how we can calculate the coverage. So as you said, now I'm going to add CG sample. Actually one is enough, but I will check once again. Whatever we write in real time, it's total different. Okay, so 100% covered. Okay, all are covered. See, 0 1 2 3 all are covered, and here 0 1 2 3 all are covered. Okay, so next here also all are covered. 0 0 0 1 1 2 3. Okay, so but here why it is still 25%? What still need to cover?
There are more combinations for A and B.
See here we took only 0 0 0 0 here. Okay, so 0 1 and 0 1. But if we do cross cover, this 0 can cover this 1, and this 0 can cover this 0. Like that, this 0 can cover this 1, and this 0 can cover this combination, and this 0 0 can cover this 1 1 combination, right? Like that, this A can cover this B combination, and 0 1 can cover this combination, and this combination, this combination, and this. Like that, 1 0 combination to 0 0, 1 0 combination to 0 1, 1 0 combination to 1 0, 1 1 combination to 2 1 1. Okay, so that is how we need to check in the cross coverage. But functional coverage means any value is the same. but we get more number of hits. Okay, so I will show you that thing in the next session. So you can write 002 01 combination 012 10 11. We can also write loops here. Zero 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 one 1011. Okay, so you need to write sample for all. Actually, sample no need to write for all. I will check once again. Instead of that, we can write some command here. In functional coverage, we don't write. Of course, in functional coverage, we don't need all these things because we don't create any design in the functional coverage. So, see, all 100%, even cross also 100% because all conditions are clear, right? All combinations. So cross coverage is also 100%, but before we got only 25%, right? So that is how we can check the coverage. Everyone understood till here? Hello.
I have one doubt, ma'am. What is meant by test case and bin coverage, cover point? What are the difference between these terms, ma'am?
Okay, see, test bench means, okay, I'm taking this example, suppose. Okay, so here this is a test bench. Suppose test in the sense there is a design. Okay, so here if you observe, this is a design. For the design, to verify this functionality, sum is equal to a plus b. To verify this functionality, we are writing here test bench. Okay, we are calling as a test bench. Test case means what? We create different test 1, test 2, just same as like this only. Test 1, test 2, test 3 we create. In that we write a b scenarios, a equal to something, b equal to something. Suppose in this how you can take, how you can divide as a test number of test cases. You can divide into 4 test cases because this 0 0 combination um, is one test case. Okay, and this 0 1 combination to remaining B combinations are in one test case, and this 1 0 combination to 4 combinations another test case, and these combination you can put in another test case. So 4 different test cases are getting here. Okay, so simply those are nothing but test cases. Okay, in the design we need to write bins means suppose these combinations I'm taking in the test. Okay, so we need to cover these things in the coverage, right? Just a second. So here these things we will put in a test case 1, and here test case 2, in this test case 3, and here test case 4, divided like this. Okay, so test cases is nothing but simple plan. Okay, how you will write a test plan for this plan in the sense how many number of test cases are there, what is the use of each test case, and each test case what functionality is going to verify by each test case. Okay, so that is the test plan. If we go further complex projects, there we will have lot of things. There will be different blocks, interfaces will be there, and test id also we can create because this test id, what is the id in the sense number, because there will be thousands of there hundreds of test cases, right? Practically we create some ids also. Okay, and which block related to which block it is related to, like that we will write whole information. Okay, that is what test plan we call. Okay, in this case how we can write the test plan? So test case 1 is going to cover a with the 0 0 and remaining b combinations. Test 2 is going to cover a with the 0 1, b with remaining possible combinations, and here 1 0 remaining combinations, 1 1 remaining combinations. So this is what actual functionality. To verify the functionality we are creating test cases. So how we can understand whether we are verifying all the possible combinations or not? We need to check the coverage. Okay, so simple, you can understand. Before we got 25 percentage cross coverage, 25 percentage. Okay, so in that we need to understand, okay, why we got cross coverage as a 25. We covered all combinations 0 0 0 1 1 0 1 1, but cross coverage means what? This case to remaining cases, and this case to remaining cases we need to cover that. So whenever we are whenever we are using coverage concept, then we are getting to understand, okay, what we need to cover in the functionality. Okay, if you don't use coverage concept here, you will simply you will simply check, okay, all combinations I have verified 0 0 0 1 1 0 1 1, 4 combinations verified, I got the output. So that is verification part. But coverage point, in the coverage point of view, every bit by bit, every cross coverage, cross in the sense, this is the perfect example. Okay, so like that every corner case it will check. That is the main use of coverage. Did you understood now?
Then what is bin, ma'am?
Bin in the sense, see, bins are nothing but two. to write the coverage, see, cross coverage means directly we put the cross A comma B. That is one syntax for cross coverage. Code coverage means in code coverage we don't write any bins, just we can put enable. Before I used dollar enable, right? Uh, dollar coverage enable. So like that we can put. But in functional coverage, we need to write the bins. Bins are nothing but see here example. So this is the test case. Okay, so in this test case what we are covering, 2 4 6 8 10 12. Okay, so to hit to check this number of tests are covered or not, we write the bins. See here, ignore bins. So 1 2 8 10. Okay, so here 1 2 8 10 means ignore bins, means we need to ignore those bins. Other than that, we need to cover remaining bins. That is ignore bins, illegal bins, wildcard bins. There are different types. Common example, if I show common example, see here, bins. Um, low bins low 0 to 9, bins high 10 to 15. Why we are writing like this here? Because if you observe here, A is a 4 bit. Okay, 4 bit means total 16 combinations will be there. Okay, in that 16 combinations, that means 0 to 15 combinations, we need to cover all 15 combinations. We need to write the test case and we need to cover all 15 combinations. Those we need to check through bins here. So in the cover group, so this is the main cover group. So in that we written the cover point to check the value of A and to check value of B, two cover points. In that, how we are checking bins low A. Low and high means low is a LSB part and high is MSB part. So low means here it is checking 0 to 9. High means it is checking 0 to 15. So within two bins we completed here. Not only two bins, we can create 10 bins, 20 number of bins, like that. Okay, we need to what we tell, we need to classify that. Okay, how many number of possible ways are there. Okay, so that is what number of bins. Same here, you can divide into 4 bins also, 0 to 3, 4 to 9, and 4 to 7, 7 to 11, 11 to 15. Like that you can divide the number of bins, 4 bins, and here also 4 number of bins, but simply we can also take in this way. Okay,
Yes, ma'am.
clear everyone? So in the functional coverage, you will get more clarity. No need to worry about the bins now. Okay, because we are going to work on a lot of examples in functional coverage. Okay. And next, any other doubts? Others? Everyone got clarity on code coverage and cross coverage?
Yes, ma'am.
Ma'am, for line coverage and branch coverage also, we need to write separate code or it will come under that code coverage, ma'am?
Code coverage only. Line, path, branch, loops, FSM, everything on code coverage. As a design engineer, we no need to worry about the code coverage. Our goal is functional coverage and toggle coverage. Toggle coverage also we don't use here. Once you go to the industry, there we use toggle coverage mostly. But as of now, we need to concentrate on functional coverage, and you will get the questions from functional coverage only.
Okay.
Ma'am,
Okay.
for branch and line, we don't need to write anything.
Branch and line.
For branch coverage and line coverage, so we don't need to write anything explicitly. It will generate automatically.
Yeah, we
Or
need to write the sample. For code coverage, we need to enable the coverage. Automatically, it will generate. Okay.
ma'am, if we have hundreds and thousands of inputs, so we have to write sample for each individual input.
Not each individual input. We don't sample each individual. As I told here, we write the bins. In the bin, if you observe here, 16 combinations are there. 16 combinations we don't sample individually. We need to write in terms of bins. So all bins will sample at a time. See here, my coverage dot sample. No need to write individually. Before we didn't write any bins, right? That's why here we use the sample concept. Every value we sample, but if we write all in one bin, no need to sample every value. Okay. Everyone clear?
Yes, ma'am.
Okay. Okay. Mostly code coverage is nothing but we use cross coverage in code coverage. One of the classification is cross coverage. Okay. Okay, so I will share you some assignment on code coverage and some of the questions in like test. Okay, so go through that test, everyone attempt, and you can check how much. Okay.
Ma'am, also share the link of the recorded session, ma'am, in our
I
document.
already shared the session link in the same sheet. I'm adding those.
Okay.
Okay.
And
Okay.
Ma'am,
Then
and the coverage PPT also.
hello.
I already shared the PPT before this session, right? I will add these codes in the same sheet. You can go through the codes and PPT. I already shared before the session in every group.
Okay. Yes.
And ma'am, we can also get the recording.
Yeah, you
Uh,
also can get. I will share you. Okay.
okay.
Yeah. Okay. Okay then. All. Thank you.
Thank you, ma'am.